Hello, this is Dr. Lukes, and we're going to be looking at the graphic portion related to the Lab 4 activity, in which we are trying to estimate something where we have a number times an integral of dy over y minus yi. And to do this, what we need to do is estimate what the values are of y and yi, and we need to do these so that we get evenly spaced. And I said that we should get about 10 intervals, okay, which means 11 or more data points. And so first thing I'm going to do is divide up my line here. And if you measure the length of the line and then come up with what those lengths of the subintervals need to be, and then you can mark those out along the length of your space. Okay, not very much fun watching me do this, I realize. But anyway, so you're going to go through and mark out those evenly spaced intervals. And I must have mismeasured when I did that. But anyway, okay, so they're evenly spaced, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I will make another one up there. I'll just extend my line to make it work. All right. So then we need to, these lines that connect y and yi are based on something that is about mass transfer coefficients. It's the negative slope of the mass transfer coefficient for the liquid divided by the mass transfer coefficient for the gas. And that's going to be a constant, and then that's going to determine a slope. And so once we know what that slope is, what you want to do is from each one of these points, draw a line with that slope. So once you get one counted out, just draw all the rest of them to be parallel. Okay, now that's not the slope that I gave you, it's just a slope. Then these points here, this is the y value, this is the yi for each one of my little intervals. So I'm going to read across and read these values. So for the first one I have y is equal to 0.173 and yi is 0.1234 Okay, then what you want to do is find your function, which is 1 over y minus yi. So that's going to be 1 over 0.03. And now this is going to be your f of y, this column here. And you're going to do that for each one of these points all the way down. And you'll see that they, vary in the distance y minus yi. But you're reading over to the y-axis for each one. So this is going to be your f sub y, and you're going to do that for each one of those. Your delta y is going to be based on these numbers here. So 0.163, for instance, is my next y. And so you're going to be able to then do an estimate. If you get an even number of subintervals, then you can use Simpson's rule. If not, then you must use trapezoid rule. Simpson's rule will get you a better estimate. It's a little bit of a slow, tedious process, but once you get these values of y and yi for each one of your lines you created, the rest of it is just simply a matter of plugging it into your Excel spreadsheet and then evaluating the integral. Thank you very much for your time.